And again, as we have discussed last week, it's all about computational complexity. See, the pattern of information that in the case of vision is hitting your retina is very ambiguous, and we're going to discuss, and I'll give you several examples of that. And yet, our minds seem to come equipped with processes that allow us to resolve this ambiguity in a way that works for the environment we live in. Look, I've given you a similar example last week, but look at the image that is on the screen. If I were to ask you, what's happening out here? What is actually out there? You would probably say, well, there's a square and there's a circle. My guess is that that's the first thing that came to mind. But of course, we've seen a similar example, as I said last week. It could be there's a square and a Pac-Man, whatever that shape is, that just happened to be placed so that the edges of the square are perfectly coincident with the edges of the Pac-Man. And it could be an infinity of possible things that these two shapes actually are. Yet, you assumed it was a square that is partially occluding a circle. Now, maybe if we had evolved in a world where there's tons of Pac-Man all over, maybe we would have thought Pac-Man. But that's just not the world we live in. The world we live in has more circles than Pac-Man. So it makes total sense that our minds have evolved through evolutionary times, the assumption that what's out there is probably a circle occluded by a square. And look, take this other image. It's a wall, right? It's a very simple wall, and you see it in perspective. But why do you see a wall? Why don't you see, it could be an infinity of things. Why don't you see a cigar sticking out of the wall? You see it? If you don't see it, again, enjoy it, because once I show you, it's impossible to unsee it. But in fact, in this image, even though you're seeing a wall, there's a cigar sticking out of it. Ready? Pause it if you don't want to see it, and if you want to kind of look harder at it. Right here. I don't know the origin of this picture, but somebody took a picture of a cigar sticking out of a wall, and it's kind of hard to see it until you actually see it. And once you see it, it's impossible to unsee it. But again, you spontaneously, I mean, you might have seen a cigar right away, which is perfectly fine. Cigars can stick out of walls. Right? But you probably just saw a wall. Your brain just reconstructed a wall. And what's crazy, your brain missed something so obvious as a cigar that is right there sticking out of the wall. But of course, it's reasonable, given the colors and the shapes, to infer that there's a wall there. Here's another example, and I've shown you a similar one last week. Look at squares. Look at squares A and B. I am fairly confident that A looks to you very dark, and B looks to you very bright. In fact, if I were to ask you, you'd say A is dark gray, and B is whitish. It just happens to be under the shadow cast by that cylinder. Are you sure? Maybe by now you've learned to expect that I do my best to embarrass our brains. And I should clarify, when I show these little tricks, they don't mean that our brains don't function well. They're just ways to expose the strategies. It's like a window into how our brain works. These are little ways to expose the strategies that our brains use to reconstruct the world. Again, the information that reaches us is very ambiguous. And so we need to reconstruct it. And to reconstruct it, we often make inferences about what can be, what can't be, what's happening out there. And see, in this image, you've reconstructed A as being a dark gray square, B as being a white or sort of light gray square. It just happens to be under the shadow cast by that cylinder. But is that what is happening? Let's see. And I swear to you, there's no trick. I'm not using Photoshop. In fact, you can print the slide and look at this yourself. Actually, A and B are exactly the same color. I know, right? It's fun. Here, look, I'm gonna I'm going to put a line between the two. They are exactly the same color. See what's happening, and this is similar to to the big cube with the colored tiles that I showed you last time. What's happening is that even though these two are the same color, your brain sees that there's a shadow here being cast by the cylinder, and so it assumes that even though the color it sees is the same as that, the real color that is here must be brighter. It just, even though the wavelength of the light that is hitting your retina from this square and this square is identical, the brain sees that this one is under good illumination, whereas this one is under a shadow. So because there's a shadow, your brain automatically says, okay, they do have the same they're the same color, but one is under a shadow. This means that the real color of the tile is probably lighter. It just, it's made darker by the shadow. So your brain automatically adjusts these two and makes B seem much lighter than it actually is, than the color that is hitting your retina actually is. And again, it suffices to hide the shadow to reveal this trick. And again, if you connect them, they're perfectly identical. Feel free to take my slides and sort of cut out the image and assure yourself that it is the way I'm saying. I believe, if I remember correctly, the book also shows you the same thing, but in a slightly different way. So you can, if you don't believe me, you might believe the book. And so again, this is the way in which our brains face computational complexity. And importantly, this really shows that perception is not an exact process of we take what is out there and we just recreate it in here perfectly. Perception is an inference. Is your brain taking this information that comes in through some informational medium and using it together with knowledge, using it to reconstruct what might be out there. And it works most of the time. I mean, you and I interact with the world just fine. We see the world pretty well. We represent the world in our minds pretty well. We don't hit stuff all the time. We're able to interact with the environment fairly appropriately most of the time. So the inferences our brain makes clearly work, and it makes sense. They were developed to work in this world. Sometimes, interestingly, there actually are multiple ways of reconstructing an image out there. Take this image, which is known as a Necker cube. What is interesting about it is that there are two possible interpretations of this image, and they're both equally fine. In this case, there isn't an interpretation like the square over the circle that is better than, or that is more likely than the interpretation of the square with the Pac-Man. It just so happens that there's no reason to prefer seeing the green vertex as being the one coming out towards you versus the pink vertex being the one that is coming out towards you. You can see this image both ways. This is known as a bistable image. There just is, in this case, there's no guiding principle to prefer seeing the cube as sort of having one as kind of coming out this way with the towards the bottom left, with the green vertex being the vertex out, or coming out towards the top right with the orange pink vertex being the one that is sticking out.